Good evening and welcome to another episode of Maths in an Empty Classroom with me, Mr. Sutton. This is part one of the first lesson on geometric series, and in this video I'm just going to be explaining what a geometric sequence is and the formula for finding a term and for finding a sum. So what I have on the board here is the first four terms of a geometric sequence, and it goes 3, 12, 48, 192. And what I want you just to think about is what the term-to-term rule of this sequence would be. So just pause the video for a moment and think, right, what do I have to do to each term to get the next one? Right, hopefully you've realised that you're multiplying the previous term by 4. So 3 times by 4 is 12, 12 times by 4 is 48, and 48 times by 4 is 192. So whenever you have a sequence where to get to the next term you're multiplying by a value, that is a geometric sequence. Okay, so different to an arithmetic sequence which goes up or down by the same number, a geometric sequence is about multiplying, so we call it a common ratio. I'll talk more about that in a moment. So what I'm just going to do to show you a little link to where some of the formulae come from is rather than 12, just above it, I'm just going to write 3 times 4, because that's what we've done to get 12. We've done 3 times 4. Now above 48, I could write 3 times 4 times 4, but what I'm actually going to do is I'm going to write 3 times 4 squared. To get from 48 to 192, we have done 3 times by 4 squared and multiplied it by another 4. So it's 3 times 4 cubed. Now if I work my way back through the sequence now, I've got power 3, power 2, well power 1 on the 4, makes perfect sense. If I were to write this as 3 times by 4, the power would have to be 0, because as we know 4 to the power of 0 would be 1. So the nth term rule for this sequence would be that term n would be 3 times by 4 to the power of n minus 1. And if you look at that, the first term in the sequence, 0, second term, 1, third term, 2, fourth term, 3. So each term in the sequence, the power of 4 is 1 less than the position of the term. And this holds true for geometric sequences in general. We call the first term A, so A is the first term, and then the next term is obtained by multiplying by what's known as a common ratio, which we call R. So the second term would be AR, where R is the common ratio. So, first term, second term. To get to the third term, we'd multiply by r again, so we would have ar squared. And then to get to the third term, we would have ar cubed, etc, etc. And what you'll notice is, second term, r to the 1, third term, r to the 2, fourth term, r to the 3. So we can write the general rule for finding the term as term n is a times r to the power of n minus 1, where a is the first term, a number, and r is the common ratio. So if I wanted the 8th term, I'd do a times r to the 7. If I wanted the 15th term, I'd do a times r to the 14. If I wanted the 100th term, I'd do a times r to the power of 99, etc, etc. So this is the formula for a term. Another one that you need to use, which I won't derive now, but there is a proof for it, is the sum to n terms. And there's actually two versions of this. I'm just going to commit to this one. I like my students to have one formula they commit to. So the sum to n terms, I'll write that this is sum, is a, so first term, multiplied by 1 minus r to the n, so however many terms you're trying to sum to, all over 1 minus r. So if you know a, the first term, and you know r, the common ratio, you can substitute those values in to find the sum to a given number of terms. One quick point before I end this video is we've seen this sequence here, 3, 12, 48, 92, where the value of each term is increasing. If we had something, for example, like 27, 9, 3, 1, and I were to ask you, what are you doing to each term to get the next term in the sequence, you probably would say you're dividing by 3, which is true, but because r is a common ratio and it's all about multiplying, instead of saying divided by 3, we would say that we were multiplying by 1/3. So for this sequence here, a, the first term, would be 27, and r would be 1/3, and it is crucial that r is what you are multiplying by. So sometimes it can be a fraction. Okay, join me in the next video where I'll do an actual numerical example of finding a term and a sum for a geometric sequence.